Alrighty, here we are on lesson 14, computing actual lengths from a scale drawing. So example 1 says the distance around the entire small boat is 28.4 units. The larger figure is a scale drawing of the smaller drawing of the boat. State the scale factor as a percent and then use the scale factor to find the distance around the scale drawing. So first, we need to put in that our smaller one, this is our original, and this is our scale. Okay, so the difference between what we're doing now and what we've been doing is that we only have, one given measurement right now, which is the distance around the entire small boat. And we want to know the distance around the entire boat. So that means that we're going to have to use measurements that we find ourselves on the picture. So we're going to start with our original boat first. And when we're looking at things we want to measure, we probably want to measure nice horizontal or vertical lines. So let's do the horizontal line here that they both share. And if we measure this horizontal line here, this is 1, 2, 3, 4, 5, 6, 7, 8 units. Alright, and then if we do the scale, and we do the horizontal drawing here, and we measure that across, we get 22 units. So we want to use those to help determine our scale factor. So when we go to do our scale factor, remember that it's always scale over the original, so it's going to be 22 over 8, and when you divide that you get 2.75, which is the same thing as 275%. Okay, but that's not what the question is asking us for. The question is asking us to use that to help us find the distance around the scale drawing. So that means we are going to take the distance from the original drawing that they gave us, which is 28.4, and we're going to multiply by our scale factor, which is 2.75, and when we do that, we get 78.1 units, and this is around the scale drawing. Alright, and that's kind of going back to what we did in the first lesson. Okay, let's go ahead and flip over. Oops. Alright, and we are on exercise 1 now. It says the length of the longer path is 32.4 units. Oops, that didn't really underline very well. The shorter path is a scale drawing of the longer path. Find the length of the shorter path and explain how you arrived at your answer. Alright, so our original is going to be our longer one. So the bigger one up here is our original. And the smaller one down here is going to be our scale drawing. Okay, so again, we know the entire length of the original. We want to know the entire length of the scale. So we're going to pick, a nice line that we can count the units on. So how about this time we do a vertical line. And when you count the vertical line here, you get 9 units. And if we do the same thing on the scale drawing, you get 3 units. Okay, so now we are going to use this to help us find our scale factor. I'll do that over here. So for scale factor, remember it's always scale over original, so this would be 3 over 9, which we know is 1/3, which would be 33 1/3%. Okay, so now if we want to find the entire length of our scale drawing, we're going to take our original that we had, which was 32.4, times our 1/3, right? If we were to change that percent to a decimal, but we're going to keep it as a fraction, we would get 10.8 units. And that's our answer. Okay. So go ahead and flip the page. We are going to skip this page right now, and we're going to go over to example 3. So example 3 says race car number 2 is a scale drawing of race car number 1. So first, before we go any further, that means that race car number 1 is our original, and number 2 is our scale. Okay. It says the measurement from the front of car number 1 to the back of car number 1 is 12 feet, which they give us that, while the measurement from the front of car number 2 to the back of car number 2 is 39 feet. If the height of car number 1 is 4 feet, find the scale factor and write an equation to find the height of car number 2. So let's start with our scale factor first. And remember, it's always scale over the original, so we're going to use the measurement that they both have. So this would be 39 over 12. And you divide that, you get 3.25, which is the same thing as 325%. Alright, so what we want to do is we want to write an equation. So remember, scale factors are k, and we always said that our equations were y equals kx. So that means it's going to be the same thing here. Our equation is going to be y equals kx, and it's going to be y equals, or k is 3.25x. So now if we go in and we're trying to find our height of our scale drawing, we're going to use the one from our original, and it's going to be the same idea of what we did in that first lesson. It's going to be 3.25 times 4, and when you multiply that, that gives you 13. So that means that this up here, our height of our scale drawing, would be 13 feet. Okay, so the equation is just another way to represent our scale factor and all the things we've been doing from the first few lessons. Okay, we're going to look at exercise number 2. It says determine the scale factor and write an equation that relates the vertical heights of each drawing to the scale factor. So first, we are going from drawing 1 to drawing 2. So that means drawing 1 is going to be our original, because they give us both measurements, and drawing 2 is going to be our scale. So to find our scale factor, first we have to use one that they both have, and remember it's scale over the original, so it would be 3.3 over 2. And this gives us 1.65, which would be 165%. So our equation then would be y equals 1.65x. And if we're trying to find this measurement over here, that means we would have 1.65 times, and if we take the measurement from the original, 1.1. And when you do that, you get 1.815. So that would be our measurement here, and it would be centimeters. Okay. And our last one here, exercise 3, says the length of a rectangular picture is 8 inches, and the picture is to be reduced by 45.5% of the original picture. Write an equation that relates the lengths of the picture. So first, we need to take this percent and we need to make it a decimal. So this would be 0.455. So we go and we write in our equation, which would be y equals 0.455x. And we're trying to find the length of our scale drawing. So that means we take our scale factor, 0.455, times our measurement from the original picture, which is 8. And when you get that, you get 3.64, and that would be our answer, and this would be in inches. And you're asking, does that make sense? Well, they told us that it needed to be reduced, and this is reduced from the original, so yes, it does make sense. Alright, we're going to go back to that other page during class, so we're going to stop right here. So make sure if you have any questions, bring those to class tomorrow.